What's up, guys? I've got Matt Lee here with me today, and we're going to spend a second talking about this Azure DDoS attack. It's a very interesting story, purely because of the sheer scale of what went down. So let's dive right in and take a look. I'm going to share my screen here, and we're going to look at some of the news reporting and some of Microsoft's own reporting, and then do an interesting comparison with Google's math tools. So this is The Verge, and it's a source I tend to look at for geek news, but they covered this. You can see this on any sort of cybersecurity news, technology news site. The interesting thing about this attack, like I said, is the sheer size of it, right? 2.4 terabits per second. That's a huge amount of bandwidth. Microsoft's undersea cable network that they're building does about 26 terabits, right? And the really cool thing about this, and you see this spike, this is the graph of the attack. And it's all the way up here, and it's short bursts, but that's really all it takes at these numbers. But the interesting here is it was absorbed, right? So they attacked a customer in Europe. The entire
like
attack
a
was
speed
absorbed.
bump, right?
Right.
Azure absorbed it like a speed bump. And what these attacks are meant to do, and just to kind of quickly go into it, is to take a service offline. They were attacking someone. They were probably extorting someone, saying, "Hey, listen, I'm going to take you down, and when you're down and you're screaming, we're going to let you know, and we'll bring you back up." Or they might not be bringing them back up. And if they take those services down, that's real loss of money. It could be a real loss of life, depending on the services behind it. But these attacks are meant to overwhelm the capacity of a server to respond. So for them to just eat that and not even, skip a beat, it really is actually something to be lauded, I think, in my opinion. And it's great to see their systems in place to solve some of these things. So
it's impressive. I think it's the second, from what I've been reading, and it's probably all over the place, but it's the second largest DDoS attack recorded by bandwidth. Cloudflare sort of took that cake at 2.7, so we're close. Huge amount of bandwidth. So I'm going to put these links in the chat. This is actually Microsoft's explanation. Now, they only say a customer in Europe, of course, not going to tell you who was attacked.
Right.
But again, this is 2020's number. We're at around 1 terabit, right? Versus 2.4 in this August attack. So it was really incredible engineering on Microsoft's part and distribution of the network to be able to absorb this much traffic.
And they've designed it, right? But this is the first time they actually get a cannon of that size pointed at them for a 10-minute period of time. And for them to just be able to absorb it to the extent that the threat actors realized it was non-efficacious and stopped. It's pretty interesting.
Surely champagne was had in Redmond after this. I mean, it's just crazy. Like, you can't test for this, right, guys? Like, you can't test. Like, how do you test 2 terabits of you just don't, right? It's not.
Maybe you could like rent a threat actor for a day, right? Like borrow a botnet program. You bring your botnet to work program. But anyways, but how much data is that, right, Dom? So if we think about what that calculatively is, so to help me out, help explain this to our readers here and listeners here.
Yeah. So let's look at this in terms of bandwidth. It's pretty interesting. So gigabit internet is a pretty common thing. Now, you don't get true gigabit, and we all know this, but let's say you do get true gigabit, right? 214.4 terabits was the total attack, right? And if we look at that and compare that to gigabit, so 214,400.
Right? It's a factor, a massive factor there of 214,400 compared to so it's a lot of.
So that's to say, if your neighborhood has 214,400 houses and they all have true gigabit, you would have died in this attack, right? But if there's 214,401 houses, you would have barely survived. So it's a very, very powerful attack. Matt, I think you have some sort of stats on what this type of attack was and sort of why it was impacted. So I'm going to switch to your screen here and we'll take a look.
So I want to talk about, what is a DDoS attack, and more specifically, what is a UDP-based amplification attack. And essentially what they're doing is they're taking advantage of some of the structure of how these protocols work and using them to weaponize them and to hide their true identities. And so what happens is you look at the definition from CISA. This was a release in 2014, TA 14017A TLP White for release, and it was last revised in 19. And they go through and discuss, but what they really talk about is say, okay, overview. a DDoS, or distributed reflective denial of service, or DRDoS, which nobody's implemented as a terminology, but those type of attacks rely on publicly accessible UDP servers and bandwidth amplification factors to overwhelm a victim system with UDP traffic. And to think about this in tech terms, UDP is a protocol that is connectionless, but it's also a protocol that doesn't have a way to validate directly the source of that IP protocol other than looking at routing and other methodologies that are out there. But essentially, you could rewrite who you are. So instead of me being Matt Lee, if I wanted to attack someone, I'll say, you know what? My name is Dom Kirby. Please reply to me at Dom Kirby with this piece of data. And the request is very small, but the response is very large. And so what happens is Dom gets more data than I could actually give him myself, right? I could only generate one datas, and the response might be 10 datas. And so the 10 datas make it to Dom, and I actually only had to send one data to elicit that. And so that's where you have an amplification factor. And so I want to kind of show what that looks like. And so how does a DDoS attack work? Well, Cloudflare kind of puts it out and says, it's kind of like a highway with cars. You can only fit X number of cars. And let's assume that all of the cars are the baddies, right? And all of these cars are these vehicles, and they have occupied the road so that the goodies, and I like green, so I'm going to change this. Sorry. And a little bit but all the good people can't make it on because the threat actors have occupied the network in that sense.
Right.
And so I also want to talk about like what are the types of attacks, right? They happen at several different layers in the protocol, and application layer and transport layer methodologies. But in this instance, let's talk about what a traditional DDoS used to look like. A threat actor had a bot network. That's probably your toaster, your internet connected fridge, that hair dryer you can't live without knowing its overall throughput statistics and have it connected to the internet, right? These stupid things. But the bots, and the Merari botnet's a great example, but there's tons of them, then would make a TCP request, right? So traceable back to the bot. They could be blocked because the source IP addresses very easily, and you have this targeted victim. And so it's a one-to-one attack. It's a flood in TCP.
Right.
But protocol attacks that get more effective, and SYN attacks is a different methodology we can talk about. It's more like, hey, I'm here, but then not answering the phone when someone calls, so they stand there for a second, and it overwhelms the resources of the server. A DNS amplification or UDP amplification attack, DNS specific in this instance, I can't draw, but and I'm also a Listexic. But a UDP attack is where the attacker controls a bot, and there's probably thousands, if not hundreds of thousands of bots. In fact, Microsoft said that the number of distinct people responding was 70,000. I just show off how bad my hand-eye coordination is, but is 70,000 different distinct entities attacking them. And what they'll do is the bot is the first victim, and they'll ask the bot to say, hi, I'm Dom, and ask a DNS server for information. And that information would say, hey, give me the total TCP dump of all of this record information. And I'm being a little hyperbolous. But instead of replying back to the victim or to the attacker, it actually replies to the victim, the intended web victim that you're trying to take out. In this case, an Azure VM in Europe. And so each of these responders are amplifications for two reasons. Number one, the bot's making these calls one-to-one, but they're amplifying 10 times or 5 times or 50 times or 70 times, right? And then in the same breath, you have each of these being repeated very easily because I have many of these bots able to do this along many different distinct infrastructures. And so you see it coming from Cox and Comcast and AT&T and Verizon and all of these different sources of this data that you can't just one-to-one block because they're already spoofing and lying about where they're coming from and pretending like they're here. So you can't block yourself as the responding request. And so you can start blocking these DNS servers, but that takes a lot of time to mitigate. And Azure was able to walk through that extremely quickly.
There's 70,000 of them, right?
Yeah.
So it's kind of like those Google business calls or car warranty calls. You can keep blocking them, but they're just
going to keep coming. And so for Azure to just walk through that, like they didn't even like it was a high school defender and they just stepped over his head as they're running with the ball, right? Like, or the boxer that just holds the little kid out this far at arm's length, he's swinging, right? Like it is really nice to know that Azure's infrastructure and methodologies they planned in place to protect this one targeted victim didn't have extortion capacity. In fact, if you look at the graph, you almost see a little bit of a start, a stutter start, and then down the road another big blip. But there was gaps in there as they gathered more resources. There were things in there as they waited for the rest of the botnet. And then there's like, man, this isn't going to work. Like, I guess we're just done here, boys. Let's wrap it up. And so you saw this, drop of that attack method because they don't want to waste resources either, right? There's other things that could be done with that. So just one of the great example to walk through of the escalation. I remember when we called it 100 gigabit cannon. now we call it a 214,400 gigabit cannon, right? I mean, is that what this
Right.
would be?
It's impressive. I mean, it's a lot. So it's something to think about too, right? If you're looking into cloud, and Azure's not the only one with this capability.
Yeah.
Cloudflare is blocked huge.
Yep.
We talked about 2.7. So definitely, think about this and realize that this is something that's going to continue to happen, and things like UDP reflection are sort of the next evolution of an attack we sort of thought we'd figured out. And I think the only way to really deal with this is to black hole it. And to black hole it, you've got to have the infrastructural capacity to black hole it, right? Like, this is hitting edge, this is hitting core, this is right.
You can't do it on
everywhere.
a modem. You can't do this on a cable modem, right? Like,
right.
And you take it in is that sometimes these threat actors use DDoSes as a methodology of confusion and distraction during actual aggressions and thefts and actual attacks on organizations to tie up security teams, right? And so if you have something where you're not even aware of the DDoS because it's just been mitigated as part of an infrastructural providership of your company, like, that's amazing when Azure just stops it so that your security teams can focus on the real threat that's coming in that distracted time. So,
right. Yeah. So that's it, but I did realize, and I made a mistake, and I'm a big fan of one take. So we're just going to admit our mistake and correct it real quick. True news reporting here.
I love it.
I typed in 214.4 in here. Not 2.4.
So I have to take back all my 100,000 iterations. Yeah. That's unfortunate.
24. I'm like,
it's still huge, but it takes away my hyperbolous argument. Like, no, I'm teasing. It's still absolutely gargantuan.
We'll say megabits, right? Like, most of your internet connections measure megabits.
That's what it is.
Anyways.
You were just being smart enough to know that people were in 100 megabit connection, and this would be an easier approximation for those humans. I like how you got there, Dom.
So yeah, again, DDoS is something that you really can't mitigate against at the SMB level unless you're behind the right infrastructure. I look forward to reviewing more of these spectacular attacks. I'm sure 2021 is not done throwing us for a loop yet. So until next time, thanks for coming, Matt.
Stay safe.